30th May GFG question, closest neighbor in a BST. So basically we are given a BST and they're saying that you have to find the closest neighbor. Now what is closest neighbor? Suppose we're given 14 as our question, 14. The closest neighbor of the 14, it's 15 by a raw, but the question asks that the closest neighbor should be less than this particular value, 14. So basically we have to return 11. And this is nothing but the floor value. If you know the concept of floor and ceil, floor is basically a number that is less than or is equals to a particular target, and ceil is basically the number that is greater than or is equals to a particular target. So here they're asking just find the floor in this language, closest neighbor and all. So we have to find the floor of a particular key that is given. Here the key given is 14, so we have to return 11. We just have to return the integer value. So what is the brute force approach first? The brute force approach is that, this is an BST. That is why the in-order traversal of a BST is always sorted. So that is why you can literally do the in-order traversal using the recursion function or iterative approach using stack, whatever you like. You just perform the in-order traversal and you just store all the elements that you encounter in that in-order traversal. For example, in order is left, root, right. So first you will encounter 2, then you will encounter root, so that is 7, then you will go right, that is 8, then this root, then you will go as left as possible. This is left, this is root, this is right. So you will get the in-order traversal. So you suppose you store this entire in-order traversal like this, right? Then what you do, then you try to find, then you simply do a linear traversal and find the what is the element that is most near, that is less than is equals to this particular 14. So you will simply find with the if condition, you can find this 11, right, in your array. So, but a better approach is that you don't store the array, that is the brute force actually. So to optimize this, you can do the recursion and you can keep a track of a variable, either a global variable, or you can pass that in the recursion, that the last value that you've seen that is less than is equals to, this target value, right? And once you start to find things that are greater than target, you can directly return, because in an in-order traversal, you will never be able to find a value smaller than a particular value afterwards, right? Because it is sorted. Even in recursion, it is sorted, right? So you can also do iterative search. So here we are going to do iterative search. It is nothing but a binary search kind of approach. Just see, suppose this was an array. What can you do in this array, right? You can actually do not linear. You can actually, when you store the array, you can also perform binary search. Because the in-order traversal is sorted, right? You don't have to do linear. So the time complexity would be, well, it would be O of n, because you have to store the elements, and that will require O of n. And then in order to search, that will require log n. But rather than storing, we can directly perform the log n using the iterative approach. So suppose what we're going to do, we're going to compare our key with this 10. Is 10 less than is equals to 14? Yes, it is. Then we are going to store 10 as our possible candidate for our answer. 10 can be our answer if all the elements are greater than 14, suppose, other than 10. Then 10 can be our best possible candidate. That's why we are going to store 10. And there is no way that we should go left, right? Because in the left, all the elements would be less than 10. And we have to go as close as possible to 14, which is greater than 10. So we're never going to find it in the left side. So we will move to the right side, that is 15. Now 15 is greater. So that means there is it doesn't make any sense to go any more right. Because if you go right, you will find all the elements that is greater than 15, greater than our target, that is 14, right? So we will try to go left. This is how we will keep eliminating the half search space, right? And when we are at 15, we are not going to update our answer candidate, because the answer candidate has to be less than is equals to 14. So when we move to 11, okay, yes, this is a better candidate than 10. That is why we are going to update our answer to 11. And then we are going to actually move right, because in the search of better candidate, what are better candidates here? 12, 13 and 14. You can find them in the right side of 11, but there is nothing. So we are going to stop and we return 11. So it's literally the simplest code. This is the answer variable. We have to return an integer. And you can also store this root in a temp if you don't want to modify the actual values that are passed and all. But we are just traversing simply. If the key that we found is less than is equals to, we store as our candidate and we move right. Otherwise we move left and return the answer. As simple as that.